For this next problem, let's take a look at the sieve of Eratosthenes and describe what it is used for. The sieve of Eratosthenes is a technique for determining prime numbers. And basically the way that the technique works is we eliminate all the composite numbers so that the prime numbers are left. To get the idea across, let's start. I've listed out here the first 435 positive integers. First thing we're going to do is get rid of the number 1. 1 is not a prime number, so we'll just simply cross that one out. The next thing we'll do is get rid of all of the even numbers. So we'll keep 2, but we'll get rid of all the even numbers. And those, if you see, will be on diagonals that go like this. So just kind of do this and get rid of all the even numbers. Now this will take some time, so let's go ahead and do this. And you may want to convince yourself why the even numbers appear on diagonals. I'll give you a hint. It's because that the number of rows across is 15, which is an odd number. Okay, so we've got this candy stripe pattern, and all the numbers that have not been crossed out are the odd ones. Okay, so that's the multiple of 2. The next prime up is the next uncrossed out number, which is 3. So the next step is to get rid of all multiples of 3. So we'll do that in orange. So if you notice, the multiples of 3 are going to be in columns. 15 is a multiple of 3, and so 12, 33, 48, 63, those numbers are multiples of 3, and so we'll just get rid of all of those. And this will take a little bit less time than getting rid of the multiples of 2. Okay, so 2, 3. The next uncrossed out number is 5, and so the next step is to get rid of the multiples of 5. Before I can do that, let's take a look to see what isn't crossed out yet. So 2, 3, 5, 7, 11, 13, 17, 19, 23. You notice those are all prime numbers. The next number, 25, is not prime because that is 5 squared. So we've gotten rid of all the multiples of 2, the multiples of 3. So the next uncrossed out number is going to be the next prime number squared. In other words, all the primes, all the numbers that are less than 25 are prime numbers. So I can just circle those. So 2 is prime, 3 is prime, 5 is prime, 7 is prime, 11 is prime, 13 is prime, 17 is prime, 19 is prime, and 23 is prime. Okay, so we've made a fair amount of headway already in listing out the prime numbers. Next off, we'll get rid of all the multiples of 5. And again, those will appear in those appear in the columns because 15 rows across, is a multiple of 5. And so just getting rid of these numbers, those are the multiples of 5. Okay, so according to my logic, all the numbers that are uncrossed out that go up to 49, 7 squared, are going to be prime numbers. So that leaves us with 29. Oops, turn back to circles. 31, 37, 41, 43, and 47. And the next unprime number that's left is 49. Okay, so let's start crossing those out. So let's now take out the multiples of 7. Now, you should convince yourself that because 15 is one more than a multiple of 7, 14, to get rid of the multiples of 7, we go diagonals going the other direction. Let me get the line tool back on. So if I go like this, in this direction, starting from multiples of 14, multiples of 7, then all the numbers that appear on the diagonals are going to be multiples of 7. Okay, so coming down this way, 1. So notice I went 1, 2, 3, 4, 5, 6, 7. Coming down this way, 1, 2, 3, 4, 5, 6, 7. 105. Okay, 301 is a multiple of 7. Let's make sure that actually is correct. If I take 301 divided by 7, 43. Okay, coming down again, 1, 2, 3, 4, 5, 6, 7 at 210. And carefully drawing the diagonal. The number that appears here is 406. And 406 divided by 7 is indeed 58, so that works. Okay, coming down again, 1, 2, 3, 4, 5, 6, 7, 315. And then drawing in this diagonal. 427 is the number I just got there. Let's double check that real quick. 427 divided by 7 is 61. So 1, 2, 3, 4, 5, 6, 7, and these last two have already been crossed out, but let's do it anyway. Okay, so what I've done now is crossed out all the multiples of 7. So the next prime number is 11, so that means going up to 11 squared, or 121, I've got all the prime numbers. So let's circle those. So everything up to 121 is prime that isn't crossed out already. So 53, 59, 61, 67, 71, 73, let's see, 79, 83, 89, 97, 101, 103, let's see, 107, 109, 113, and then 121 is the next number that isn't crossed out. That is a multiple of 11. Okay, so next off we get rid of the multiples of 11. This one will take a little bit more delicacy. To get rid of the multiples of 11, the lines are going to take the shape of going 1 down and 4 over. So 1 down, so I don't want to start on 11 because 11 is prime. So 22, start here, 1 down, and then 1, 2, 3, 4 over to 33. So those are going to be a little bit more crossways like this. Okay, then if I were to go to 44, which is over here, then it's 1 down, 4 over to 55. And then 66 over here. and 77's over here. So these kind of go sideways. You notice that it looks like 43 has been crossed out, but it really hasn't. Okay, now there's no point in doing those lines up here, to be perfectly honest, because we already know that all these numbers are prime. Where we need to start is at 121. The next non-prime number is going to be 11 times 13, which is 143. Okay, then 1 over and 4 across. 1 down. 2, 4 across. Doesn't get me anywhere, so that'll stop there. Okay, the next non-prime number is 11 times 17, which is 187. So 1 over, 1 down, 4 across. 1, 2, 3, 4. Like this. It's 198. The next non-prime number is 11 times 19, which is, let's just cross this one out for simplicity's sake. Next non-prime number is 11 times 19, which is 209. Next is going to be 11 times 23, which is 243, which has already been crossed out. Sorry, 240. 11 times 23 is 253. I apologize. 253. 11 times 29 is 309. Sorry, 319. Then we go to 11 times, so that was 11 times 29. Next is 11 times 31, which is 341. Next would be 11 times 37, which is 403. Next is 11 times 41, which is 451, which is off the chart. Okay, so going up to 435, that's as good as we can get. Okay, so that's the 11th. So going up to 13 squared, which is 169. Everything up to 169 is prime. So let's keep going. 137, or actually 127. Oops, need the circle tool. 131, 137, 149, 151, 157, 163, 167, and 169 is 13 squared. Okay, next up is the multiples of 13. Multiples of 13 are handled by crosswise lines again. So we'll go 13, and the lines here are going to be not as painful because 13 is 2 less than 15. So if I go 1 down, 2 across, those will be the multiple of 13. Then if I go over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That takes me to 210, 210, I believe. I'm sorry, I misspoke. Go to 13 times 17. That'll be the next non-prime number. That's multiple 13. That's 221. And so 221 is right here. So if I go here and then go 1 down, 2 to the left, all of those numbers are multiples of 13. Let me continue that the other direction. One, 2 across, one right, 2 up to 195, which should be a multiple of 13. And indeed, 195 is 13 times 15. Okay, now the purple lines like this, I can now that I've got to 195 here, I can start just simply go down 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then just go across like this. So 1 over, 2 across, and then 1 down, 2 across. And then 1 down, 2 across. And so those will be the multiples of 13. Now let's make sure this actually worked. If I do 13 times 19, that's 247, which should be crossed out right there. If I go 13 times 23, the next non-prime number, that's 299, which wasn't crossed out. My fault. So 299. 1 down, 2 to the left, 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 and then I can't go any further than that, so we'll stop here. Okay, let's see if that's all of them. 13 times 29 is 377, which is what I just did down here. 13 times 23 is 299, which I just did. 13 times 31 is 403, which is what I have right here. And then 13 times 37 is 481, which is off the chart. Okay, so this means that everything up to 17 squared, which is 289, that has not been crossed out is a prime number. So let's start circling those. 139. Forgot to circle before. Let's see. So starting at 163. So 167, 173, 179, 181, forgot over here, 197, 199, 191's over here, 193, 211. Remember, I'm going up to 17 squared, which is 289, 223, 227, 229, 233, 239, 241, 251, 257, 263, and 269, 271, 277, 281, 283, and then 289 is 17 squared. Okay, so let's now start knocking out the multiples of 17. So 17 times 17 is 289. So we'll start eliminating those in dark blue. So if I go, because 17 is 2 more than 15, if I go 1 down to the right, all these will be multiples of 15. So that's 17 times 18, then 17 times 19 is the next one, 323. And then if I just continue on this direction, so 1 down, 2 to the right, 1 down, 2 to the right, those are the multiples of 17. Continuing, let's see. So next non-prime is 17 times 23, which is 391. Then 1 down, 2 to the right, 1 down, 2 to the right. Next is going to be 17 times 29, which is 493 and off the chart. So we've taken out the multiples of 17. Okay, so that means if I go up to 19 squared is 361. Then everything that is not circled up to 361 is prime. So 283, 307, 311, 313, 317, 331. Remember, going up to 361, 337, 347, 349, 353, 359, and finally 361 is right here. Okay, now we're getting down near to the bottom, of course. So next prime number is 23 squared, or sorry, 19 squared, pardon me. So 19 times 19 is 361. Get rid of that in light green. Oops, thought we were going to get rid of that in light green. The next non-prime would be 19 times 23. 19 times 23 is 437, which is off the chart. Okay, so that means basically we're done. Everything that is not been scratched out is going to be a prime number. So let's finish circling those. 367, oops. 383. 379's over here. Coming down this way, 397, 401, 407, 409, 419, 421, 431, and 433. And unless I missed one, which is very possible, looking back I don't see anything right now, but that should be basically all the prime numbers less than 435. So that's a sieve of Eratosthenes. It's a very visual way, looking at it in a table like this, of removing multiples, removing all the composite numbers so that only the prime numbers are left. And because I went to 435 here, if I take a look at the square root of 435, that's 20.85. So that means if I knock out all the primes that are less than 20, so 19 or less, then I'm guaranteed that what's left are all the prime numbers less than 435.